So I do want to get started. Today we're going over parallel lines and transversals. So in chapter 3, we're going to be looking a lot at parallel lines and a transversal and what type of angles are created. Shh. Quiet now so we can get started. So you have time to work on your assignment. So parallel lines are coplanar lines that do not intersect. Okay, so you have parallel lines, they do not intersect. They lie in the same plane. The symbol for parallel is just two parallel lines. They're kind of slanted. Okay, so in the picture at the right, you do have two different parallel lines here. These arrows in your parallel lines do not mean they're congruent. Those arrows indicate that they are parallel. Okay, so if you see arrows in lines there, it means they're parallel. It's not saying that they're congruent. Okay, so those are parallel lines. Now we also have skew lines. Okay, those are lines that do not intersect and are not coplanar. Okay, so these two lines don't intersect, but they're not considered parallel, because to be considered parallel, you have to be coplanar. So skew lines are those lines that lie in separate planes. This is really hard to show. Okay, so if I have a line here and a line here, these two will never intersect, right? Okay, those are skew lines. Okay, one's going this way, one's going this way. They lie in separate planes. They will never intersect. That's what skew means. Even though if I show it like this, you can kind of see they kind of cross like that, but technically they don't. Okay, that's what skew means. So, with the person sitting next to you, what is the difference between parallel lines and skew lines? You gonna do that on your test?
Yeah, I'm just stand up in the ACT. So
I think your teacher would be like, what are you doing? Sit down.
sign language.
Alright, so what is the difference between the two? Difference between the two. We know they both don't intersect anything. What's the difference though? One is
not coplanar.
yeah. So one of them is coplanar, the other is not. So parallel lines must lie in the same plane. Okay, and skew lines lie in different planes. Okay, so those are our lines. Now we can also have parallel planes. Okay, so those are planes that do not intersect. Okay, so those are planes that do not intersect. So if segments and rays are contained within lines that are parallel or skew, then the segments or rays are parallel or skew. Okay, so if you have these lines, okay, the rays within that line are also parallel to each other. The segments within that line are also parallel to each other. Okay, so I have two parallel lines here. Okay, the rays that I can create, so from the endpoint over, from that endpoint over, those rays are also considered parallel. Okay, so that's all that's saying. So we're going to do some examples with parallel segments and skew segments and perpendicular, because you know what perpendicular means. So in the figure, identify each of the following. Number 1, which line is parallel to line FE and contains point B? So we have line FE right here, and point B is over here. I need a line parallel to FE. So it needs to be going in that same direction and containing this point. Okay, so that would be this line right here, and that is AB. Okay, so I can write line AB. Okay, number 2, we need a line skew this time to FE containing point B. Okay, so it can't go in the same direction because those lie in that same plane. But if I go from B to C here, those two lines will never intersect. Okay, and it's in a different plane. So it is CB. Okay, so that would be a line skew to line FE. Okay, the last two have to do with perpendicular, okay, meaning they form that right angle. So number 3, which line is perpendicular to, again, FE, that contains point C? Has to intersect, right? Perpendicular lines have to intersect. So it has to be this bottom one right here, and that is CE or EC. Okay, it doesn't matter your order for those letters. Okay, last one, number 4. Line that is perpendicular to FE and contains point D. Which line is that? Containing point D, perpendicular to FE. FD. Okay, perpendicular lines have to intersect. Okay, they must intersect. Okay, questions on those 4 problems there? All right, so the ones at the bottom here, okay, we're referring to this image off to the right. So we're still finding parallel segments and skew segments and then a couple planes here. So I'm going to work through number 5 and then I'm going to have you do some by yourself. So number 5, we want to find all the segments parallel to segment QX. Okay, so QX is this one right here. So I need the segments that are parallel to that one. Okay, well, I would have NE parallel to segment QX, right? They'll never intersect, so I can write out NE. What about MH? Is that one parallel to QX? Yes. Okay. I could make a plane and those two would lie on the same plane. So MH is also parallel. Okay, what about TO? Is that one parallel? Will those intersect? They will not intersect. These are parallel. Okay. Next one. Again, I'm just looking for segments that go in the same direction as QX. So this one, SG, also goes in that same direction. You could create a plane between those two to make them lie in the same plane. So SG is also a parallel segment. Okay, and then the last one is this one right here. Again, they lie on that same plane in this squared area. So RA is also a segment parallel. Okay, those are my only segments that are parallel to QX. Okay, so when you're looking for parallel, you have to look that they're going in that same direction. Okay, they have to go in the same direction to be parallel. All right, so I'm going to have you do 6, 7, and 8. For number 6, there are 6 planes that intersect that one. 6 planes that intersect that one. For number 7, there are 3 segments that are parallel to QR. And for number 8, there are 8 segments that are skewed to AG. Okay, so I'm going to give you a little bit of time here. Talk with the person sitting next to you. Try and find each of those, and then I'll go through them.
That are parallel to QR.
How many are in?
And then XA.
Eight on for 8? I have 4.
Alright,
Oh,
so
and then it would be.
let's talk about the skewing segments. H for our 8. It's QR, OH, ME, NE, X. Wait, did I just name them all? If it's
Right, I
O,
have 8. There's QR,
got 'em.
TS, MT,
What?
NQ,
Oh,
QX,
yeah.
NE,
Oh, well,
NH.
for number 8, since they all skew to AG, you tend to be like X, Q, R, S, R,
No, I just said
no,
SR is parallel, not skewed.
not skewed, parallel,
So,
skewed.
yep, this one's parallel, this one's parallel, and this one's parallel.
So the rest of them.
Except for the ones that intersected.
Alright, so,
And then these ones here don't either. So like HO, if you were to extend those lines,
okay, so, but then wouldn't MT eventually too?
no. Because MT, this is one plane, this front one.
Yeah, I see.
So make sure you look at this 3-dimensionally. Look at it 3-dimensionally.
MN is a parallel section.
I'm missing one. I don't know what one
Did you get the front and back one?
And then the back
The hexagonal planes? The hexagonal planes right here? In the front and the back?
No, I want to figure out myself when it's independent.
Number 6.
Yeah, so you have like this hexagon in the front, right? That'll intersect HS. Right? You just need 3 letters. So you can do G, A, H, that's fine. And then the same thing with the back one too.
ME is not
I wanted to expand so I didn't quite want to fit that.
Yeah.
You are.
So you have this whole. So you have this one.
So all planes that intersect plane MH, so plane MH is huge.
These ones will extend
Right? So it's talking about that two.
Yep.
So
These planes are, they keep going. So you're so from
M is parallel A, N, QX. No, so MTO.
Okay, so I had MTO and NEX. Those are the only ones that can be logical.
Well, you extend the line.
Extend infinitely. So for planes, you're either parallel, or if you have a sideways plane, they will extend
Like this.
and eventually intersect each other.
This one extends like this.
So which one is sideways that would eventually intersect that top
But
line?
this line extends
The ones that aren't parallel.
So this way, making it eventually intersect SG. It's the fifth dimension, buddy.
I have started doing writing next week.
Yeah.
Oh, I have AG. You know
All right, so I know some of you are still working, that's okay. But I do have to get to the back side of our note sheet, so I'm going to start going over this. So for your planes, for number 6, planes have to be labeled with 3 letters. Okay, now with those 3 letters, you have to remember that planes extend infinitely in all directions. Okay, it's not just a finite area. Okay, it's not just in one spot. So this top plane here, MHE, actually extends all the way in every direction. Okay, so it will be a flat surface that extends. So my planes that intersect, we can see an easy one off to the side right here. Now it doesn't matter which 3 letters you use, so I can just use MTO. Okay, that'll just label this plane right here. Another easier one is off to this side. You can see they share that side NE. Okay, so I can label this one NEX. Okay, so that's that side plane right there. Okay, then you have your 2 hexagons. Okay, on the front and the back there that will also intersect. This front one shares this side HE. So again, you just need 3 letters to label that plane. Okay, and they have to be non-collinear. So I can use O, H, and E. And then the same thing in the back. Okay, I share this side MN, and then I can just go to one of the other letters. So T, M, N. Now, for the other 2, like I said before, your planes extend infinitely in all directions. So with planes, it's either parallel or they intersect. Okay, so I do have one parallel plane to that one. It's this bottom one right here. That means these other 2 planes have to intersect that one at some point. Okay, so you're only parallel or intersecting for planes. You don't have skew planes. Okay, so this plane off to the side here will eventually intersect that top one. So I'm just going to label that one STO. And then the same thing with this one over here. If this one were to extend up, they would intersect at some point over here. So we also have RQX. And again, it's any combination of those letters within those planes. Doesn't have to be exactly how I labeled it. So that one was kind of difficult. Number 7, this one most people had. So the segments that are parallel to QR are segment MT, OH, and XA. Okay, so those are the 3 segments that are parallel there. Now, for number 8, your skew segments to AG. So you're looking for segments that are not parallel. Okay, so SR is parallel to AG, so I wouldn't include that one. Okay, so I'm not including that one. I can't include the segments that will intersect that one. Okay, so that would be this one, and this one, and this one, and this one, right? Now, if I were to extend AG, this segment EX would also intersect it. Okay, so EX is also not one of my segments, or OH. And then my segment up here, is that one skew? No, what is it?
Parallel.
It is parallel, so that one is out of the running as well. Okay, what about segment MN? What is that compared to AG? It's parallel, so that is not skew. So I just went through and I looked for parallel segments to that one, and I looked for segments that would eventually intersect that one, so that I would just cancel those out right away. So my segments I have left here are TS, TO, QR, QX, NE, MH, MT, which one did I miss? NQ?
Thank you.
It's front and back.
Okay, so it does kind of help to know what that skew means. So look for lines that would be parallel to the one you're given. Cancel those ones out. You know you can't use those. And then look for lines that would intersect. Cancel those ones out. Can't be those ones. Okay? I have 8, yeah. Did you at least get some of those for that last one? Questions, labeling. Parallel, skew, perpendicular. And for the last one, it doesn't matter the order of your letters, so it could be flipped, so ST instead of TS. That's fine. All right. Then on the back, this is some stuff that you've done before in middle school. So we are going to talk about lines intersecting other lines. So a line that intersects 2 or more coplanar lines at different points is called a transversal. Okay, so this is called a transversal. So in the diagram, line T is the transversal because it intersects lines N and M. Okay, so your transversal has to intersect both of those lines. So here we have line T intersecting both N and M. Okay, so it cuts through both of those, and it does create 8 angles then. So we have interior angles and exterior angles that are created. So you have 4 interior angles that lie in the region between N and M. Okay? So between your 2 lines that get intersected, those are your interior angles. So angle 5 is in between or inside. Angle 6, angle 3, and angle 4 are all interior. They're in between those 2 lines. Okay, we also have 4 exterior angles created that lie in the 2 regions that are not between lines N and M. Okay, so those are the ones on the outside of those 2 lines. So your exterior angles are angle 1, angle 2, angle 7, and angle 8. Okay, so the ones on the outside of those 2 lines. So we do have more specific names for angle pairs now. Okay, so we're going to be looking at different angle pairs created. So the first one is consecutive interior angles. Okay, those are angles that are interior, hence the name. Okay, interior, that lie on the same side of the transversal. Okay, so in my picture over here, angle 3 and angle 5 are a pair of consecutive interior angles. Okay, both interior and on the same side of that transversal. Okay, so another pair of consecutive interior angles. I need my other interior that lie on the same side of that transversal. So that would be angle 4 and angle 6. Okay, the next one is alternate interior angles. Okay, so again, these angles are interior. Okay, they are non-adjacent. So they're not next to. Okay, angles that are non-adjacent interior angles that lie on opposite sides of the transversal. Okay, so they're on opposite sides. That's what that alternate means. Opposite sides of your transversal, but they have to be interior, so in between. So angle 3 and angle 6 are alternate interior angles. They jump across that transversal and lie on the inside. So another pair would be 4 and 5. They have to jump across that transversal. Okay, the next one we have are alternate exterior angles. Okay, those are non-adjacent exterior angles that lie on the opposite sides of the transversal. So again, that alternate piece means the opposite side of your transversal. So jumping across. Now with these ones, they're exterior, so that means they have to be on the outside. So angle 1 and 8 are alternate exterior. You still jump across that line T, but they are on the outside. So your other pair here would be 2 and 7. Okay, the last type are corresponding angles. Okay, those lie on the same side of the transversal and on the same side of the lines N and M. Okay, so they're the same through and through. So angle 1 and angle 5 are corresponding. So 1 and 5, same side of the transversal and both above line N and M. So another pair would be 2 and 6. Okay, same side of that transversal, both on top. So here I can write angle 2 and angle 6. Okay, I can do the same thing but below those lines. Okay, so if I start with angle 3, its corresponding angle would be 7. Okay, on the same side of that transversal, both are below those lines. So angle 3 and angle 7. Okay, what's the last pair? Yes. Okay, so angle 4 and angle 8. Now you can abbreviate these. I abbreviate them all the time. So the first one, consecutive interior angles, is CIA. Okay, consecutive interior angles. Okay, next one is alternate interior angles, so AIA. Then we have alternate exterior angles, which is AEA. And then corresponding angles, I just label as CA. Okay, so if you don't want to write out the whole thing, just abbreviate it using the letters, that's fine. So I do just want to do a couple examples of labeling here. So first we want to identify the transversal and then classify which type of pair of angles they are. So letter A, we have angle 10 and angle 16. Okay, so 10 and 16. To find your transversal, you need to find the line that hits both of those angles. Okay, so does line L hit both of those angles for 10 and 16? No. Does line N hit both of the angles for 10 and 16? No. Does line Q? Yes, so line Q is your transversal. Okay, so finding your transversal, you have to find which line hits both angles. Okay, next I want to label what type of angle pair they are. So these are on the outside, since I know this is my transversal. They're on the outside of those other two lines, and they jump across. Okay, so I need an exterior, because they're in the exterior. And if I jump across my line, that means it's alternate. So 10 and 16 are alternate exterior angles. Do another one, 4 and 12. Okay, so 4 is here, 12 is here. I need the line that hits both of those angles. Which line is that? N. Okay, now those angles lie on the same side of that transversal and on the same side of their lines P and Q. Okay, so we have same side of the transversal, same side of the lines. Those are corresponding. Okay, we just have two more. Okay, so C, we're looking at 12 and 13. Okay, the line that hits both of those angles would be line Q. Okay, line Q hits both angle 12 and 13. So that is your transversal. Now those two angles lie on the same side of the transversal and they're both interior. So both interior and on the same side of that transversal. Which angle pair is that? Consecutive interior angles. Okay, so if you need help, look back up at the examples. There's only 4 different angle pairs.
AIA.
Last one is 3 and 9. What's my transversal? N. And they are both interior and they jump across that transversal. So they are alternate interior angles.